All right, so yesterday I was looking at the models, yesterday night's runs, the OZ runs, 18Z runs, and I noticed something pretty interesting. So a lot of you probably know about the cold outbreak that's about to come over the eastern part of the U.S. and the big warm up is gonna happen in the western part. You might have seen in the news. The outbreak is already started out in on the west central areas of the United States. The cold air is gonna make its way east in the next couple of days. Should arrive to the East Coast by Sunday. And I'm not sure if any of you know about this either, but there's a tropical storm, very weak tropical storm at that, that's been affecting some of the Lesser Antilles, Puerto Rico, U.S. Virgin Islands, those areas, like St. Thomas, what this teacher says, some heavy rain there. And Philippe, I don't know if I said Felipe before, but it's pronounced Tropical Storm Philippe, from what I understand. That is going to take a turn north now, and the intensity isn't going to be off the charts, but it has the potential to affect Nova Scotia and/or the northeast United States. And the timing of both this cold outbreak and Philippe is going to be pretty similar at the same times that they're affecting the northeast United States. So something very interesting might happen, and we're going to get into that in this video. So if we look over here, this is the National Hurricane Center's forecast for Philippe. Today it has moved north of the center, at least. It's moved north of the Caribbean, north of Puerto Rico, and it is expected to continue northward now. So it should affect Bermuda, not as a very strong tropical cyclone. I believe 50-mile-an-hour is forecast. We'll check the forecast real quick after this. So it should pass pretty close to that. Probably pass pretty close to the island. And I would say the forecast is reliable up to day 3. Past day 3 starts to get a little bit uncertain as to what's going to happen. So the Cohen actually does a pretty good job, as all the National Hurricane Center forecasts do. Does a very good job of painting where it's going to be around landfall, somewhere in between. I would say probably the most extreme case would be brushing Cape Cod, and basically in between there and pretty much the western portions of Nova Scotia. That's where it could make landfall. And after that, I'd say it could go this way, that way. We'll get into that later in the video. That's going to be the interesting part. So continuing on with Philippe, not Felipe, Philippe. We can see tropical storm force winds expected in Bermuda. Still wide area, probably all the way from Rhode Island to the extreme eastern parts of Nova Scotia, even up into the Belcher Islands and James Bay up here. This archipelago of islands, Belcher Islands in James Bay. So this system is going to get really, really big as these systems gain latitude. They become much larger. As any cyclone gains latitude, it becomes larger. So we look at the visible satellite imagery. The low level center seems to be once again under convection, so that's actually a good sign developing. I think it's over here somewhere. Low level center. We can see finally some outflow starting to stream northward, but still extremely sheer tropical cyclone. Convection is very well displaced from the low level center, which is probably around here. Convection down near Puerto Rico, USVI, British Virgin Islands. Some convection off the center to the east center. So very, very sheer tropical cyclone, which has been pretty much the theme for the cyclone over the past very, very long time since it was formed. It was just getting sheared to death. It's a miracle almost that it stayed alive pretty much. So if we move on to looking at where this thing could head, if we look at the intensity forecast, National Hurricane Center is calling it for it to be 45, 50 knot storm, not anything higher than that. Models are pointing to maximum 60 knot storm, around 72 hours, between more like 60 hours, more like around here, around just after Bermuda, around Bermuda is where it could hit peak intensity. Not a very strong storm. And after that, it'll decline in intensity. It'll probably start making extratropical transition. We'll move on to that soon. And now let's look at what it could do later. So let's say, look at the GEFS track density. If we look at all the potential cases, the deterministic GFS is taking a landfall into Nova Scotia as of the O6C run, and it's making a big loop into northern Quebec, northern Ontario. That isn't Ontario, isn't it? Yeah, northern Ontario, even into the James Bay, and moving over here, moving out into Canada, making a big loop-de-loop almost. And so is actually the GFS mean. It's curving it into Quebec, mid to northern Quebec areas. Um, so what's going to be interesting is as we move on to that cold outbreak, the cold outbreak is going to be something like this. It's going to be over here. We're going to have a big upper level low that's going to form, and it's going to coincide with Philippe. Yeah, this was the GEFS track density forecast. Just showed maybe it's bigger now. If you guys need a better look at it. And if we look at the just the total density, all together, the ensembles are turning it into Quebec, somewhere in between Maine and Nova Scotia is where they favor landfall, taking it into Quebec. And I think one of the most important things with this system is that if you look at how the ensembles have trended over time with this system, it has actually been a very, very large amount of change. So blue is the oldest ensemble runs, and black is the newest one. Dark reds are the newest ones. So we look back when this thing formed, we thought it was just gonna recurve into the Atlantic as most storms have been doing. But as we got closer, we saw that this is gonna have some erratic motion. We thought it was gonna move more westerly actually instead of recurving, then recurve. And then it started moving southwesterly, which was very erratic motion. And then we thought, yeah, okay, it's gonna recurve into the Atlantic. And then it kept on trending further and further westward. And like, okay, now it's gonna recurve further west into the Atlantic. And then it started affecting the Caribbean. And now we're like, okay, so this is probably gonna get somewhere near the Canadian Maritimes. And we see it get all the way over here to where it is today and yesterday. And we're like, okay, now this has the potential to affect Nova Scotia or the Northeast United States. So this has been the trend pretty much overall. So let's move on to now the temperatures with the cold outbreak. So Climate Prediction Center, October 9 to 13, below average temperatures across mid-Atlantic, across the northeast, and above average temperatures in the central western United States. So this is probably more of the eastern cold outbreak, but I'll show you how it's going to progress pretty much. So today, this is the National Digital Forecast Database 2 meter temperature anomaly for the maximum temperature. So all across the west, except for pretty much the west coast, where it's going to start getting warmer, because we're going to get our positive Pacific North American pattern. So if you can see what my mouse is doing, positive Pacific North American pattern has a high pressure located over the west, and that forces a ridge, not necessarily high pressure, but a ridge over the west. So if you were to picture the jet stream, we could have the jet stream going like this, a big ridge, and then there's a dip in the central U.S., bringing a trough across the eastern part of the U.S., and that trough ushers in colder temperatures. So positive PNA, warmer than average for the west, cooler than average for the east. Negative PNA, cooler than average for the west. We have that trough over the west, and we have a ridge building over the east. So currently we are in a negative PNA, but that is very quickly switching to a positive PNA if we look at the next couple of days. So now we see it's getting way warmer across the west coast. And now what's going to happen actually is instead of the single trough bringing the cold air all across, that trough is actually going to die out a bit. We'll see that in the model loop soon. And some more cold air is going to seep in, a new trough is going to come in. And watch that cold outbreak. Look at how cold it's going to get across the Dakotas. Temperature anomalies of negative 20 degrees Fahrenheit for the highs, 20 degrees below average for this time of year. And that's going to feel pretty fall-like, if not close to winter. And again, then we see that moving into, by Saturday, we see that moving into the Midwest. And this is the day on which the rain and stuff is gonna move into the Northeast. And then after that moves out, we're gonna get all the cold air coming on Sunday. Look at on Sunday, we have 25 degrees below average nearly in areas in West Virginia, the mountains. It's gonna get very cold out there. It might even snow in the mountains. We'll talk about that very soon. Same thing in the Adirondacks, Catskills, Whites, potential snowfall out of this. And Monday's continuing the cold. Tuesday it's cold, but not as cold. And we see another negative PNA setting in over out west. This warm bubble is going to move again east. And look at that Wednesday again back. Oh no, that's this Wednesday. But again, this is going to move east. This is just as far as the National Digital Forecast Database goes. But some warmer temperatures are going to move back into the east, but not as warm as they're going to be today. Today actually it is 83, 84 where I am today, which is more fitting for like June or July instead of October. So this is due to again that trough coming in. So if we look at right now the cold outbreak moving in, this is today 2 p.m. All of the ensembles, every single ensemble combined, mean height anomaly 500 millibar heights. So we look at that. We look at the cold air moving in here. and that really starts to kick in by 60 hours on what is that, Wednesday, Thursday, Friday. Friday is starting to move in really, and then we see by Saturday it's really digging in, and by Sunday we can see that we have 540 for the mean, just for the ensemble mean, 540 millibar heights with that low pressure, whatever low pressure is going to be centered over there. So pretty cold conditions. Definitely fall-like for a lot of the seaboard. Moving closer into New England might even be winter-like for some people out there. And then that's going to fizzle out over time as we get a new ridge building out here in the west, positive PNA pattern. All right, so now let's just move on to what both of these are going to do combined. So we know that we're going to have both a cold, along with Philippe, we're going to have both a cold outbreak and Philippe at the same time. So let's look at Philippe as per now. Look at Philippe, what it's going to be doing. So it's going to be moving northward. This is the HWRF model. Going to be moving northward. It's going to start elongating, potentially extratropical transition after Bermuda. This is the HWRF is saying landfall Nova Scotia, potentially second landfall in Maine. And watch this. It's going to curve back. Look at 970, 980 millibar low pressure. Massive area. Look at that. Look at the influence of this low pressure. That big. All the way from northern tip of Quebec down to the Delmarva is the influence of this low pressure. From upper peninsula of Michigan all the way out to the Canadian Maritimes, Labrador. So really big low pressure. It's going to be causing some wind, relatively windy, not really windy, it's light variable breezy winds across the across Quebec, across the northeast. Definitely the strongest one would be associated with the landfall of Philippe as an extratropical cyclone, or maybe a subtropical, tropical, barely tropical cyclone. And then basically, if you look at what's happening, its influence is not originally this large. It's only down here. So why does this get so big? If we look, it's basically going to have the help of an upper level low pressure. From what I showed you, those 500 millibar heights, it's going to expand greatly. Right now we see the main systems over here, but if we look at the bigger isobars, they're getting bigger. So does the system. We see like a secondary center over here. It's pretty elongated center. The HAFSA and HAFSB are saying similar things, and so is the HMON. So I'm not going to show them to you because it's going to be kind of redundant. So we look at the cyclone phases. Basically, the idea is that what kind of a cyclone will this be? So this is from Florida State University, the cyclone phase diagrams. This is the HWRF model, same exact one I just showed you for Philippe. C over here, the C is current, what it is. So it's an asymmetric warm core right now. So as it grows, as it moves northward, it's gonna get a bit deeper, and then it's gonna become an asymmetric warm core. So probably somewhere around here, somewhere before landfall, definitely will start to show more extratropical characteristics, and then it's gonna turn more towards asymmetric cold core, and even kind of in the middle where we don't really know what it is, symmetric, asymmetric cold core, some characteristics of each, but definitely not going to be tropical system. We look at how deep it's going to be. So it's going to get a bit deeper, but then it's going to become shallow. Shallow is definitely the thing that's going to tell us that the convection in there is going to be shallow, not much convection. That's definitely going to show us that it's extratropical. HMON is saying a more direct transition to cold core cyclone, deep cold core. So that's also another uncertainty as to how this gets ingested into that cold trough. So there's a lot of different solutions for this if we move on to the models, the numerical models. So let's just start at forecast hour 84 from today's 12Z run, which is Saturday 8 p.m. So we're gonna ignore the CFS because the CFS is not a good model for short term forecasting. If we look at the Euro, it is just off of Nova Scotia. A lot of heavy rain across Maine, Nova Scotia. Canadian is kind of an outlier out here. It's all the way way west. I mean, way east, which would definitely be a better thing for, I guess, the Northeast, but still Nova Scotia would be affected by that. The American is the other side of the outliers, where it's making landfall near Portsmouth, Maine, with a much bigger system too. Already rain down to like New Jersey. Big system. The cold air is starting to wrap around it, which is going to be very interesting. And NAM and RDPS, basically this is the highest resolution models we can get at this time range. Past 84 hours, and we have to stick with the global models. They're both very, very similar in the location, slightly east and west of each other. They're basically pretty much like the Euro, but just slower. So we're gonna have to see how that plays out. Speed is something we don't know. How exactly it's gonna be placed between Maine and Nova Scotia, we don't know. So we're gonna have to look at how that plays out in the next couple of days. So let's look at the American model. Actually, I'm gonna show you the run that I saw yesterday. It really was an eye opener for me. The 18Z run from yesterday. So if we look at what's gonna happen if this will load up, here we go. It's loaded up. So this is running very slow. Here we go. Okay. So if we see, here's Philippe as a very, very weak low pressure. Here's our cold outbreak coming in. And now we get sort of an upper level low to, or a different low, more of a surface low, obviously. This is the surface MSLP. We got another low to form over here, while Philippe is very weak. And watch both of them merge. We almost get a Fujiwhara effect. I'll explain what the Fujiwhara effect is in a second. It jumps over here, starts rotating around. We get some snow on the backside of this in Quebec and Ontario. And then we start getting snow into the Catskills, heavy snow in the Adirondacks, snow, potentially even lake effect snow if it gets cold enough off in areas such as Buffalo. Definitely an outlier situation, but this was just showing me the potential of the system. 984 millibar low pressure as it's affecting a lot of the Northeast. And it does go away, lift, but not before producing a solid amount of snow and some pretty cold temperatures. It finally leaves on next Friday, Friday the 13th. So definitely something to be watching. So I'll move on to today's run, the most up-to-date run. I have the 12Z run for today. And we look at what it wants to say. We see Philippe moving in down there, that 1002 millibar low pressure over here. Philippe's definitely going to be stronger than that. That's another thing that has to be concerned as to the accuracy of the GFS. But again, we see that cold outbreak coming in across the Midwest. Has it strengthening, again, pretty far, not as far east as the other one, I believe, but pretty far east. West, not my bad, west. And we see the cold air wrapping around. And look at that cyclone, 975 millibar cyclone, snow in the Adirondacks, heavy snow in Ontario, lake effect precipitation potentially with those winds coming over the lakes, the warmer lakes. 977 millibar low pressure, very large system. So what this is going to do, what Philippe is going to do eventually, if it does merge into this upper level system, upper level trough. So there are a couple things that this could do. One is that obviously it's going to bring some moisture, so there's definitely going to be more rain. I'm just talking about the effects as if it were to merge with this cold trough system, not just the landfalling effects it would have in Maine and Nova Scotia, such as areas. Those would be different impacts. But it would bring more moisture into this trough, meaning potential for more precipitation, potentially more snow in places where it's cold enough. Second is that it is going to be stronger system, much stronger system. Could be bigger too. Its area of influence could be much larger. We see all the way from like northern Quebec down into the northeast and mid Atlantic. And along with that, it could be a stronger low pressure, as we see 977 millibar low pressure inland. That would bring strong winds. Well, not strong winds, really breezy winds, but to the higher peaks, it would bring some stronger winds in the northeast. And third, it's going to be, again, as I said, those stronger winds, even those upper level winds, are going to help pull some more cold air down from northern Canada, the Arctic areas. And it's going to kind of almost in a way, it could make the cold blast more potent. One thing that could throw a wrench in this is that the fact that Philippe might not fully be extratropical, so it could be still be a warm core low, bringing some more warmth into the system. But I feel that if the winds are strong enough, the low pressure is strong enough, it's going to wrap around more cold air on its backside, bringing the potential for snow in areas like Quebec, Ontario. And in this extreme case, it's bringing quite heavy snow on the north side of Lake Erie and Adirondacks. Maybe I shouldn't use extreme as the right term for this, but more like one potential scenario, as it basically the strong scenario. Look at the Euro. The Euro is saying something different. Euro definitely, I would say, has a much better handle on Philippe's intensity and position based off the National Hurricane Center cone. So the cold air outbreak across the Midwest. And basically what this is a little further east than the American. And what that means is that when this comes around, it's kind of going to go more to the north side of the trough. It's going to be further north. And in this case, the trough itself is also a little further east, I feel, in this case. So the low pressure itself is going to be further north. As we see, this is way further north. The center is up here, opposed to the GFS having it around here. So it's not going to be as much of an influence across the Northeast as the American was showing it having, because having this further north is it's still going to bring that cold air and maybe potentially for some precipitation, especially lake effect, as we can see over here. But it won't bring as much cold air because the cold air is going to be kind of wrapping like this. So it's not going to be as cold previously. We see the 540 heights for the 500 HPA heights. It's further north, so it's not as cold. We want to look at the temperature comparisons actually on Sunday afternoon. Look at the temperature comparisons between the models. You'd probably be able to see what I'm talking about as for the cold air. So there's two things that are going to bring cold. One is the system itself, and second is precipitation and clouds, which are also going to help reduce the temperatures. So let's say Euro, right? It's saying 40s across Adirondacks, which is pretty reasonable, and mid to high 40s across the lakes or near the lakes. Catskills, 40s, close to 50, and then pretty much everywhere else, Hudson Valley, coastal areas, 50s, low 60s. Canadian is similar to this, except for just even warmer. The American is way colder because, again, as I said, that precipitation and that more cold air coming around. Widespread 40s across the majority of New York State and even some areas of northern Pennsylvania, and then low 50s and mid 50s for the rest of the Northeast. Bring that cold air all the way down to the mountains of West Virginia. So really, yeah, if we just look at the 850 millibar temperature anomalies to see that cold air being brought down at the 1 kilometer, 2 kilometer height, you can see ECMWF, the Euro 1 doesn't have as much cold air coming around in the Northeast, more so towards areas in the West Virginia, Pennsylvania, Ohio vicinity. And the temperatures there still won't be as cold because it's kind of going to be kind of the steep lapse rates. They're going to cause like maybe some minor instability, some showers to develop, but still the cold not getting to the surface. Canadian is just not as cold altogether, similar to the Euro, but again, these are just anomalies. American is bringing the coldest of conditions, really cold air wrapping around the backside of that system in this case. UK Met is also pretty conservative as per the temperatures, not as cold. So I was talking about the Fujiwhara effect with these systems and how they could kind of twirl around each other with that upper level low potentially coming around that area. I'll see if I can show it to you again real quick. So the Fujiwhara effect happens when we have two cyclones, let's say two low pressures generally is what it is. And what they do is they come close enough to each other that they start interacting with each other. They start affecting each other. And in the case of the Fujiwhara effect, they start to rotate around each other. One might rotate around one, the other might rotate around it, or they might rotate around each other at a fixed center. So we look at the American model. Watch this. So we have a surface low trying to develop probably more of an upper level base low over here, while we have whatever remains of Philippe out here. Watch Philippe and how it's going to turn westward, and watch how this precipitation kind of rotates kind of more this way instead of more of a circular motion, more of an ellipsoidal motion. And you see how Philippe comes back around and makes another circle, kind of another loop to the center of the low, and then it starts to consolidate into one main low and start to weaken. But still, if you look over here, you can watch how it's kind of rotating around one different center before it starts to broaden out. So that was another interesting thing that I noted with this that could also bring some uncertainty into the positioning of the low pressures. Finally, let's wrap this up with just a potential snowfall forecast if it doesn't even snow out of the system in these areas. Let's look at the Kuchera ratio to get some accuracy out of this. So American 12Z run saying snow across Quebec to bring it all the way down to like the New York State border, like Erie border. This is definitely a pretty like outlier type forecast. It would definitely not stick this much as the ground temperatures are warm, and it would definitely not snow this much, most likely. This case could still come true, but it probably would not snow this much. And even if it does snow this much, probably around 4 or 5 inches are going to stick on the ground at most in this area with 6 to 8 inches of snow. Adirondacks is saying around 4 inches widespread. I would say definitely the upper peaks of the Adirondacks are going to get some snow out of this. So there's Mount Marcy, Algonquin Peak, things like that. Definitely going to get snow. I'd say even the Catskills, down towards the Catskills. I'm looking at some of the forecast reads. I might head out there on Sunday. Look at the Catskills. The temperature wise, it looks like the peaks are going to be in the low 40s to 30s. So we do get some moisture. There could be some flurries up in the Catskills too. Look at the European. European is definitely going to be much less snowfall than all of this. It's just saying a couple inches in the Adirondacks, high peaks, even down in West Virginia mountains. Really, I'd say pretty much the snowfall is going to only be, besides Quebec and Ontario, obviously the northern areas, the snowfall in this event in the Northeast is going to be confined to the Adirondacks. I say have the best chance, high elevation Adirondacks. And the other two spots that may potentially get some snow are the Catskills, potentially probably only the highest mountains probably getting flurries, not any accumulating snow, and the mountains of West Virginia if we can get some moisture out there to have precipitation. The reason the whites or the greens aren't really expected to have any snow is because the center of Philippe is kind of be over here, say, right? It's going to be here or here. So they're going to be under the warmer influence. They're not really going to be on the backside of the low pressure. So that's why they're not expected to get any snow at this point. But again, I'm just going to say if we want to see snow, if anybody wants to see snow out of the system, the best place to go would be the Adirondacks, the high peaks Adirondacks. And now one last thing that's done with our forecast portion. Let's talk about the Fujiwhara effect. So I will discuss it on the whiteboard right after this, but this is a great animation I found on Wikipedia of hurricanes Hillary, or tropical cyclones Hillary and Irwin merging together in the East Pacific in 2017. And so if we look over here, let's watch over here. These two systems, watch how one of them becomes dominant, the other one kind of like wraps around. So it seems like the further this system is the one that becomes dominant, and then this starts to wrap around it, and then it merges. So that's the Fujiwhara effect. I'll explain it on the whiteboard now. So if we look at what the Fujiwhara effect is, and at a rudimentary scale, it's just two cyclones rotating around each other, as I said. I'm going to take a northern hemisphere example. It'll be backwards for a southern hemisphere example because the cyclones rotate differently in both hemispheres. So say we have two low pressures, right? Both of similar strength coming pretty close to each other, all right? So low pressure spin counterclockwise, right? So wind's going to be this way, this way. So this cyclone is going to want to pull this cyclone this way, right? Say if this cyclone wants to pull this one this way, right? And this cyclone wants to pull this one this way, right? So that would be their potential motions, right? Now, do we see kind of an overlying motion within both of these systems over here? Yeah, because we see they're overlying, they're starting to rotate counterclockwise, both of them, right? So if they're both of same strength, they're going to have to come to a compromise. They're going to be rotating around another center over there, right? And now, so this is the ideal case, right? So we have both cyclones rotating around each other until they end up merging at one point. So if they're of same strength, and they're kind of the same environmental characteristics, close to each other, distance to each other, then yes, that's probably going to happen. But they don't always have the same strength, right? Say we have a stronger low pressure over here and a weaker one over here, right? So if this weaker one is anywhere, this one is going to want to pull this cyclone this way, right? But that's going to be a pretty weak force, right? And this one is going to be so much stronger, so it's going to want to pull this one too, and it's going to be much stronger force. So this one is going to wobble a bit too, but it's really going to mainly be that one. So it's mainly going to be the weaker system that's rotating around until it merges maybe at some point. The other low pressure is going to deviate very minorly from its position. So the center of rotation might be, say, here. So those are the two different cases in which we can have the Fujiwhara effect happening. One of them being similar strength, one of them being different strengths. And really, at the end of the day, what it's doing is that it's a very nice phenomenon to observe on things such as satellite. And the second is that it does introduce some variability in the potential track of cyclones. So in the case of how Philippe is going to be merging into that extratropical baroclinic low, there may be some uncertainty as to where the center of that low falls, which is pretty well shown by the models I was just showing you. So that wraps it up for this video. Thank you for watching. If you have any questions, please leave them in the comments.